Next subject to talk about is an important part of geography, and that is soil formation, dirt. What is dirt? Where does it come from? It's very important because it's the ground we walk on. But soil, in particular, is defined as a fine material, ground material, containing organic and inorganic matter. Material, ground material, organic matter. As you may know, there are many different kinds of soil. Many different characteristics to it. Some of it comes in different colors. Some of it is very loose, very porous, very wet. Um, some of it is very hard and brittle. Some's kind of dry and sandy. Some's kind of almost powder-like. But it comes from many different processes. This is defined by um, chemical and geologic composition um, and other factors. But where does it come from? Where does dirt come from? Well, weathering is the beginning soil formation. Basically, it's broken down over time. Remember, all it has different characteristics. So there are different ways of kind of defining it. There are several different classes of soil, each with its own varying individual characteristics. Example one, the geologic factor. Is the underlying rock, the bedrock. Like depth, texture, uh, and the nutrient content of soil. As often its soil's color, for example, is defined by what is the bedrock it's over. Um, they have a climatic factor. Climate's the next part of the soil formation. What kind of climate you got? Affects the temperature and precipitation in the soil. Um, Example, temperatures, precipitation, that affects the growing season, the spread of vegetation, which decays and becomes part of soil. Rate of evaporation. Um, Another part of soil, though, is humus. Humus, H-U-M-S. That is the amount of decomposed organic matter in the soil. This affects the soil's fertility. That is, as plants and animals decompose into the soil, that soil is absorbed and becomes nutrients for the next generation of plants. The whole circle of life thing. Um, but the amount of a humus, and that affects its soil's fertility. But humus, it can change considerably from area to area and from region to region. And fertility can be very different depending on just what is decomposing into it. This is why you have a crop rotation. It's very old-fashioned kind of farming where basically you let a field lie fallow, let it rest for a season while you're planting the other ones. Um, Meantime, you basically but the existing, what hasn't remains of previous crops and the plants there, let them die and decompose in the soil. Plus, you let animals graze in it using their um, waste to refertilize the soil. Within a season or two, it's usually ready to be used again. Because depending on what you grow, those plants can take those nutrients out of the soil. And if you're using too much of it, too many nutrients too quickly without replacing them, that can make the soil infertile, unable to support particular types of crops. So that's the reason why farmers add chemical fertilizers to particular fields to increase their fertility, to make sure you can maximize their yield. The geology, the underlying bedrock, climate, affects temperature, precipitation, soil. 3, the topographic factors. That's the height of the land. Aspect of the slope, the angle of the slope, particularly the direction the slope faces, facing mostly the windward or rainward side of a particular area or not. How much angle there is, that can affect what's available to form soil, where it's going to form because of erosion. But height of the land, altitude, that can determine what's there. Certain types of plants aren't going to be able to grow at certain elevations. Certain kinds of animals aren't going to be able to grow at certain elevations, and so forth. And 4th, the biological factor. Biological factor. Living and dead animals in the vicinity, the ability to add organic matter to the soil. The bacteria and fungi, they assist in decomposing organic matter. And larger organisms like worms and ants can mix and aerate the soil, that is bringing more oxygen into it. Like I say, worms are very good for the nitrogen cycle in the soil, making sure that there's enough nitrogen in the soil. And ants, of course, help basically kind of dig up and till the soil naturally and help decomposition of a dead animal, of animal remains, and so forth. And 5, the chronological factor, time. How long is it going to be? This is the length of time the preceding 4 factors have been interacting. And soil doesn't form overnight. It can take a couple of centuries to form an inch of topsoil in a particular area. But again, that's all going to depend on what all is at work here. What nature has to work with. So you got your underlying bedrock, you got your climate, temperature, precipitation, soil, kind of growing season you got, which affects what kinds of vegetation you've got. Topography, that is altitude and other factors. That's why up in the Rocky Mountains it's going to be very rocky soil, because you just don't have a lot of animals and plants up certain elevations. Sand is going to be the soil will be very sandy in the desert, because not a lot of organic material to decompose into the soil. There's not a lot out in the deserts. All adding into, yes, what's in the vicinity, the biological factor. All this adding together. All is to create dirt. Remember, soil formation is an ongoing, gradual process. Um, Younger soils can be centuries old, while more mature soils can be thousands of years old. Um, it is a slow, ongoing process. Soil is being formed all the time, and soil is, in many cases, very old. Some's been there for a long time. Some's blown away by upper layers of soil is blown away by windstorms or by a loss to erosion. But now you got the idea of soil horizons. These are the layers of soil that tend to form over time, they vary in structure, texture, and color. Layers forming over time. Now, from that, you get the soil profile. It's not a dating app. It's the vertical rows of sections of the soil. All the different sections you've got. And you start with your surface layer, the O layer. This is the very top of it. This is fresh, dying organic matter, leaves, twigs, droppings, dead insects, and so forth. Just the very top of the surface. Sometimes maybe maybe it's a tiny little bit underneath. Essentially, in this case, O is for organic. But as it starts interacting with what's under the top of it, next layer is you got the layer with O horizon, A horizon. So it goes very top where it's just starting to form, starting to sink in, and then you got the topsoil itself. A lot of nutrients in the soil and biological activity and human contact is at its highest. And little kids, we like to digging into the soil. But we'd only dig in maybe just a few inches at most. Farmers, they rely on the topsoil, but then we dig in again, maybe a couple of inches, a couple of feet. Um, and also the animals and insects living generally underground, kind of burrowing underground. Um, Moles, worms, insects, ants, and others. But this is the richest and most fertile parts of the soil. E horizon. Case E is for eluviation, or outwashing. Dig down a little bit. Water percolating through the soil. The remains of some organic matter from the bottom of the A layer. Where the E horizon starts, but it kind of depends. It's kind of where the groundwater is kind of interacting um, with the soil a little bit. And it's kind of a mishmash, a mix a little bit of topsoil and water. Tends to be very muddy. But basically, they're kind of twisting together. And you got the B horizon. This material removed from the E horizon and is deposited in the B horizon. Just kind of washes down a little bit. In this case, it's eluviation, inwashing. Now the B horizon, it's less fertile than the topsoil because not as much organic matter is making it down this far. Then the C horizon. Weathering is turning bedrock into soil particles. We've got the groundwater interacting with it and other processes. Weathering, say, a kind of sandy soils because it's breaking down the bedrock here, the C horizon. See, we're moving up and around. And then the very bottom of the soil layer, the R horizon. This R is for regolith, the unaltered bedrock. Regolith, the unaltered bedrock. Very bottom, when the soil turns back into rock. And again, the depths and compositions of these different layers, it changes from area to area. There's no hard and fast rule over it. Because now at this point you're moving not just into soil formation but also into geology. And geology, it's a measure of composition more than anything else. A lot of chemistry goes into geology. They got soil properties. Characteristic soil enable us to determine one type of soil from another. For example, different types of soil properties. Defined terms like we mentioned earlier. First, texture. Size of mineral matter in the soil and the distribution of properties of sands, silt, and clay. Loam. This is the most fertile type of soil. That 40% sand, 40% silt, and 20% clay. It's very often what you see in the kind of wash up on the banks of rivers. Combination of silt and sand and clay. Very, very fertile. Soil structure. Believe it or not, dirt has a structure to it. And that changes depending on the kind of dirt you got. It's the way the individual particles aggregate into larger clumps. Some are more uniform, some are more heterogeneous. It just kind of depends. Now, for example, suppose you have a very high humus content, a very large amount of decomposed organic matter, particularly plant matter. In that case, it tends to have a darker black texture. And particularly working with potting soil. Potting soil soiled at nurseries, it's usually kind of a dark or black soil. Why? Very fertile, because it has a lot of decomposed organic matter in it. Very good for growing plants in. Tropical or subtropical regions. Iron compounds in the soil can give the soil a yellowish or reddish color. Um, it goes some areas, soil's kind of yellowish. This isn't sand, it's actual dirt. It's kind of yellowish because maybe iron compounds in the soil. Maybe kind of reddish color. Go out to Georgia, it's very famous for its kind of red soil. There's a lot of iron compounds in the soil. Brownish blackish, it's because it has a high humus content. Leached soils. In leached soils, not bleached, but leached. Groundwater dissolved and removes a lot of minerals. It's kind of washed out. It's kind of a pale color, kind of grayish or white. A very light color. It's because all the minerals are essentially washed out of it. Soil order. As the general grouping of soils with similar compositions at horizons, weathering and leaching processes. How does all this kind of work together? What if it's washed out? How much leaching is there? What is the texture of it? How much humus is in it? What is its general composition? All soil order. And once you have dirt in an area, well, what comes next? The vegetation coming in. Succession. How vegetation in an area develops. So you may have an area that's soil allows for the creation of a grassland. Grasses start growing first. And if there's enough precipitation, well, the next thing to come along is trees are going to start coming in, larger plants, and so forth. That's how does vegetation in an area develop. And the idea of climax community. This is our self-perpetuating assembly of plants with climates in an area. Remember, as environmental conditions change, climax communities change. But succession and climax community is part of a process of natural vegetative regions, or how vegetation develops without artificial interference. This doesn't have anything to do with farming. This is separate from farming when a lot of times foreign plants are brought into an area to grow. But these vegetation regions, they differ with the climate. What kind of vegetation you're going to get, that's going to depend on soil type and precipitation and temperature. Now, for example, tropical rainforest. Rainfall is heavy throughout the year. That's a type of a vegetation region. A coniferous forest, coniferous in this case meaning cone-bearing, pine forest. Deciduous forest, more varied trees, deciduous trees. They lose their leaves during the cold season. Rainforest. Coniferous forest. Cone-bearing. Tropical rainforest versus coniferous rainforest are essentially opposites of each other. A lot of times, coniferous forests, they don't have very much rain. Sometimes they do. But it's generally a very cold climate, very cold in winters, where a tropical rainforest is warm all year round. Deciduous forest. A little mix of everything. Go out here in the woods here in South Arkansas, there's a whole mix of trees. Small trees, big oak trees, magnolia trees, and you also have pine trees. That real mix of it. They'll go into cooler areas, higher elevations. Generally, it's just simply coniferous forests, just cones, pine trees. Um, Savanna. A savanna. This is has a tropical rainfall is seasonal. Um, but generally, it's a low grassland, occasionally trees. Warm area, grassland, a few trees, not a lot. You have a Mediterranean climate. A chaparral climate. Generally mid latitudes, hot summers and mild, damp winters, and like what you'd see in the Mediterranean. Um, Desert area. Desert, again, defined as an area of less than 8 inches of precipitation per year. 8 inches of rain per year. Prairie or steppe. It's most common in North America, portions of South America, South America, and Northern Asia. Um, Essentially, again, just grasslands. And slightly different from a savanna. The savanna generally have this kind of rainy season in the summers. Prairies and steppes, you don't necessarily have that hot weather. You don't necessarily have particular rainy seasons, but you have just enough precipitation to maintain a healthy system of different grasses. This is all goes into different types of climate classification systems. Most famously is what's called the Köppen system. This defines what kind of climate we have in place. For example, you have tropical climates. Um, Next would be semi-desert or desert areas, the humid mid-latitudes, the Arctic and subarctic, and the highlands areas. Again, different climate areas which have different kinds of different types of weather patterns and different type of vegetation patterns. A lot of it again determined by what kind of soil is all depending on mixture of soil, climate, and vegetation. All it has to do a lot with soil. So dirt, it may not seem like a lot, but it's very important because it's what we're walking on, and also it's determines what kind of food is going to be grown in a particular region, if any agriculture be practiced at all, what kind of vegetation can exist, which means what kind of animals generally exist in an area. And all that coming down to the factors of geology, climate, topography, biology, and time. What you got and what nature can do with it over a long time. So that's soil formation.